Hi guys, so can you solve this WAEC indicial equation? Now this equation is actually very simple if we know what to do. Easy thing to do here. So what can we do here? How can we find the value of x in this equation? Now this is an indicial equation. It has power, base and all that. So how can we now solve for the value of x here easily? Now, in initial equations like this, like I used to say, we don't like powers and base like this, but prefer the equation to be linear, no power, nothing on top. Okay, so what are we going to do? Now, what we can do here is that we need to eradicate the base. Okay, and so we have to make the equation to be linear. And how do we do that? One idea that must be engraved in our head is that in the differential equation, when you have a to the power of x equals a to the power of y, when the bases are the same, the power must be the same. Okay, as far as the base can be the same, the power must be the same. We're going to use that same idea here. So the left-hand side, make it to have a base. Then the right-hand side also simplify and make sure they have just one base. Then we now equate their power. So how do we do that? By using laws of indices. Laws of indices are going to help us a lot here. So now, when we look at this, they have different base. Geez, this is 9, this is 3, this is 27. The bases are not the same, but we can make the bases the same. Yes, we can make them to be the same because when you notice this base, these numbers you are seeing here, they are all powers of 3 rather. You can express 9 as the power of 3, 27 as the power of 3. What am I saying is that this 9 can be written in form of 3 to the power of 2 because 3 times 3 gives us 9. So here we can rewrite this as 3 to the power of 2, all to the power of 2x equals, now we have 1 over 3. We have 1 over 3. This 1 over 3 because for this idea here now, we don't have anything like fraction. So we don't need this fraction. We don't need the fraction here at all. We don't need it. So what we can do here is that this fraction can be converted, converted to a power using the fractional law of indices. The law of indices that says that when you have a fraction, for example, 1 over a fraction like this can be converted to a negative power to give us a to the power of negative 1. A fraction like this can be converted to a negative power. So it means this here now, 1 over 3 can be converted to 3 to the power of negative 1. Okay, that's a fractional law, a law of indices, then times 27 also can be expressed as the power of 3 because 3 times 3 times 3 gives us 27. So that's power of 3 all to the power of x. Yes, another law of indices we apply here is we have the power of a power. We're going to multiply, not add, please. We're going to multiply. We have the power of a power. So here we're going to be left with 3 to the power of 2 times 2x gives us 4x, then equals to 3 to the power of negative 1. I'm not doing anything here yet. I want to simplify this first. Times 3 to the power of 3 times x gives us 3x. Now we are getting close. So can we equate the power now? Yes. No, we can't equate the power now. Yes. Why? Because for us to equate the power, they must have just one base. Students, please don't make this mistake. Don't say x cancels, this one cancels this and that. No, we must have just one single base, another single base right here. Please don't make that mistake. So what this means is that we don't like this 2 base. We need just 1. And we have to simplify this using the law of indices also. So whenever you're multiplying, right, and the bases are the same, don't forget that law of indices. When you're multiplying and they have the same base, for example, you're going to pick 1 and add their power. It's a law of indices. So we're going to pick 1 here. Here we have 3 to the power of 4x equals to 3 to the power of, we're going to add their power, negative 1 plus 3x. Yes, finally, we have made this in this way. Please always put this idea at the back of your mind. Very important, okay? Now we can now equate the power since the bases are now the same. Therefore, the power must be the same. So therefore, 4x must be equals to negative 1 plus 3x for their base to be the same. Now, don't forget, this scary exponent has been converted to a linear form. Okay, this power form has converted to a linear form. From here now, we can now solve it in a linear way that we know. Very easy. Now, please, before we go further, don't forget to subscribe to my channel. If you want to learn a lot of beautiful mathematical stuff like this, please subscribe to my channel. And as a way of supporting me to create more videos for students like this. So let's move further. So from here now, I'm sure we can do this from here now. So we can do it in 2 ways. It's either we transpose or you subtract from both sides, whichever method you want to use. But I prefer using transposition. Okay, let's transpose this to this side. So we have 4x minus 3x. It becomes negative, equals to negative 1. Okay, so 4x minus 3x gives us x equals to negative. Final answer. Very, very simple. Please don't forget to subscribe to my channel to learn more. And if you have a question, drop it in the comment section, okay? And if you have some questions for me to work with, drop it in the comment section. Till I come your way next time. Bye-bye.